Okay, so earlier we took this function f of x comma y equals x times cosine of y minus y times e to the x, and we found partial derivatives for it at the point 1 comma pi over 3. Technically, we found the gradient at 1 comma pi over 3, but that's really, if we look at one component at a time, it's partial derivatives evaluated at 1 comma pi over 3. What I'd like to do is find an equation for the tangent plane to the graph of this function at 1 comma pi over 3, and then answer what's the linearization at 1 comma pi over 3, which is not much work at all. And then let's also then do something with the linearization, do the very practical thing of use the linearization to approximate what f of 1 comma 1 is. I don't want to find f of 1 comma 1 directly. I'd like to do an approximation. So the first part we had from the warm-up, the partial derivative of f with respect to x evaluated at 1 comma pi over 3. We're just copying from an earlier slide, 1 half minus pi over 3 times e. And with respect to y, evaluated at 1 comma pi over 3, we got negative root 3 over 2 minus e. And because we're going to need it for the equation of the tangent plane, let's also find the value of the original function f at 1 comma pi over 3. This is all math that can be done by hand. I mean, you just got to know your unit circle values. It was the case for f sub x and f sub y. We did not use a calculator at all. And here we get for the actual z value of this function at 1 comma pi over 3. So this is a non-derivative work, right? This is just algebra and trigonometry work. We get 1 half minus pi over 3 times e. Okay, all of these things can be put together to create the equation of the tangent plane. In fact, this is the general form of what the equation of a tangent plane looks like. Now we just need to plug in the pieces, right? So we have z minus this z value of 1 half minus pi over 3e right there in square brackets equals, and then we have the, something that's like a slope, but it's a partial derivative with respect to x. So this number 1 half minus pi over 3e, that I just put in square brackets, times x minus a specific x value here is 1, right? And then take our other thingy that kind of operates like a slope. So that's our f sub y at 1 comma pi over 3. So this negative root 3 over 2 minus e was just copied down here in square brackets. And then in parentheses, y minus, and then we need our specific y value here of pi over 3. Okay, so this line, again, we did not really cover why this truly is the equation of the tangent plane, but it is very much reminiscent of the point slope form for a line. Okay, so that's an equation for the tangent plane. Now all we need to do to get linearization is solve for z, right? So we add what's in this square brackets on the left on both sides. And so L of x comma y is that number that was on the left earlier plus all the terms that we had on the right. That's linearization at 1 comma pi over 3. We're done with part 2. Now, the point is all of this work is stuff that we've done without needing to we have not needed to use a calculator at all. Here's the great part. Now we can use this linearization to approximate f of 1 comma 1. That is, the thing is, look, 1 comma 1 is pretty close to 1 comma pi over 3 because pi over 3, look, 3.14 over 3 is close to 1, right? So 1 comma 1 is close to 1 comma pi over 3. And so we're not getting f of 1 comma 1 exactly, we're just doing something approximate. And the point is, our approximate is f of 1 comma 1 is pretty close to L of 1 comma 1. And the point is, L is really nice to compute with. Yeah, I get that there's pi's and e's, so maybe it's a little unfortunate as an example, but the point is really the format. Look, everything in square brackets is just a number, right? So the format of L, the L function is really number plus number times x minus 1 plus number times y minus a number, right? That's really nice. And so if we just replace x and y with 1 and 1, you get a thing that looks like this. And this arithmetic, it's probably a very good approximation. And the point is, this is all written down really without a calculator. And what would you have had to have done otherwise? Cosine of 1 radian? I mean, it's just not really a question we're, settled to answer by hand. But at least what you see here, again, unfortunately, the e's and the pi's, but there's some approximations, and we could just even use pi as 3.1 and e as 2.7 and probably get really far. The point is, all of this is done to get a nicer computation at the cost of just a little bit of accuracy.